Hey Lars, I think we spoke about 2 years ago. Since then, I've been following you on LinkedIn. You've built some great thought leadership on the topic of battery electric storage and market design, specifically around electricity, capacity remuneration mechanisms across Europe. Meanwhile, me and my co-founder Jonas, we've been focusing on building a startup, Companion.energy, where we build software to support large energy consumers, typically industrials, in flexibilizing their energy demand. So it's a bit adjacent to the storage topic because more often than not, the topic of batteries behind the meter pops up. The topic of what will batteries and large-scale grid-scale battery systems will do to volatility in the market, to price fluctuations. So that's why we invited you in one of these calls, because we like to invite energy transition thought leaders to talk about their work, their ideas on the energy systems electrification journey as a whole. So it would be great if you could start off by introducing yourself, the company you work for, and what your role is.
Yeah, well, first of all, thanks for inviting me and having this talk, and happy to share some of my thoughts. So I'll start with Fluence. Fluence is the global leader for energy storage product services and digital applications for the optimization and asset performance management of energy storage and renewable assets. We have around 22 gigawatt hours of energy storage projects deployed or contracted globally. So where you're talking here in the behind the meter space, even with industrials, we have also delivered projects to industrial customers, but usually we would start around 5 megawatt hours in single projects. And the largest that we've currently deployed is, I think, 1.2 gigawatt hours in a single project in the United States. So really very large installations. My role is within the growth team in Europe. So the growth team is basically a unit of, I like to think, market experts who understand the market, who understands what's happening next in the markets, who understand the products that are out there, our own products, competitor products, who understand customer needs, how customer needs change over time. We shape policy in the markets in which we are active, and we also foster thought leadership in the markets in which we're active. We're around 12 people in our team, and within this team, I'm responsible for policy on EMEA level, which means I do EMEA level policy myself, and I'm sure we'll talk a bit about that in a moment. But I also help our colleagues in the individual member states, and I also run the Germany-based growth team. So we have, together with me, 3 colleagues dedicated to the German market, whereas I take a more European role, of course. Yeah, myself, I've been in the storage industry for about 10 years now. So from the very start, when storage was not even a thing yet, until now, where actually I think everybody understands the need for flexibility for storage, but also demand response required as part of the energy transition.
Yeah, cool. Energy transition is a great bridge, I think. What does it actually mean to you? Like the energy transition as a whole, storage as a key concept in that transition, and also a bit more detailed flexibility and demand side management, which are topics we often come across, like to talk about. They're a bit more technical, but batteries are a great mechanism to unlock those. So can you talk a bit about what these concepts mean to you?
Of course. So, I mean, let's start with the energy transition, right? The energy transition is really about decarbonizing energy systems. That's why the energy transition also looks different in different countries. France, with a very large nuclear fleet, has a different kind of energy transition than Germany, which was very dependent on coal generation and gas generation. It has an element of decarbonization, which is very important from a European perspective. In case of China, as they always say, in China, energy transition is more a matter of national security, of becoming independent from fossil fuel imports, and integrating renewables in the grid can help there. And the United States, the energy transition is basically good for your wallet, because solar and wind power are just much cheaper than burning fossil fuels. What the energy transition means for energy systems around the world, or let's focus on Europe, we integrate a lot of volatile or volatility generating resources, specifically wind and solar, and this comes with huge changes in how we need to operate the grid, but also how the grid looks. Nuclear power plants, coal power plants have been at certain locations often close to load. Renewable generation is typically very decentral in the case of solar, or very centralized where high wind resources are. And that means we need to rebuild grids and so on. It also means we have to think about flexibility in our system. Coal plants or gas peakers, you can just ramp them up when the load is there, when people want to consume electricity, but the sun is only shining during the day and the wind is blowing when the wind is blowing and then generating electricity. So we are not generating electricity anymore when we have the load, when we have the need to supply it, but we generate the electricity when the wind is blowing, the sun is shining, and we need to understand how do we match that against the needs of the power system. Therefore, we need flexibility, and flexibility can come in many different ways, shapes, and forms. So there's elements where we need to bring energy from the summer, for example, into the winter. The famous German word of the Dunkelflaute. How do we bring electricity or energy in time periods where there's very little solar and wind generation? But flexibility is only intraday flexibility, shifting the solar peak into the night. It is about what happens if clouds are covering a solar farm and generation comes only in 15 minutes later after the clouds have dispersed. What is that flexibility? And it really goes down into very, very small and smaller time steps. If we think about inertia needs in power grids, this is really flexibility within the millisecond space and responses from generation assets. And this is what new technologies can deliver. And that's where we come to energy storage. But also demand side response and other flexibility providers. They are going to be required in the power grids of the future to provide this kind of flexibility. Just to take one number, the IEA has just last week launched a report on batteries and the role of batteries in the global energy transition. And they said, as we want to triple our renewable generation by 2030, we need to grow the amount of energy storage by a factor of 6. And clearly, we also need to bring other sorts and kinds of flexibility into our power systems going forward.
Yeah, cool. And wasn't it you that proposed like an antonym to Dunkelflaute, like another word for when it was very sunny and windy? What was it again? Would be a good plug, I think.
It's Hellbrise. Unfortunately, I didn't come up with it.
Ah.
I read about it on LinkedIn. I'm not sure who it was. If you know, if anyone knows, let me know.
Yeah.
I think it's a very great word, because I think a lot about the energy transition is also about finding the right narratives and finding the right stories that people can relate to, and where they see not the change, but where they see similar patterns as they use from elsewhere. And I think this is a lot what we need to do from a storytelling perspective, on a policy perspective, to explain people things are new, things are different, but actually they're not. We're just adopting similar concepts that we use in other parts of the industry and so on.
Yeah, and I also find like developing sort of a positive set of words and indeed a positive narrative, because the negative people, they are always first with having a narrative and with like cool and fancy words like Dunkelflaute. Like in Belgium, Dutch speaking, it's a bit similar to German, but many people will know the word Dunkelflaute, but nobody will know the word to describe when it's actually good for renewables, lots of sun, lots of wind, and you can basically consume power for free. So I like the idea of that. You also talk like IEA says it needs to go with the factor 6, the growth in battery. Probably that also means like on the short, mid, and long term, a bit a shift in the role that batteries will play. I'm thinking about batteries having an obvious role in intraday balancing and the very millisecond kind of dispatching of capacity to balance the grid. But yeah, I presume in the long term we'll also need like seasonal kind of storage, and their batteries, it's not clear which kind of technologies will play a role. How do you see this sort of short to mid to long term evolution of what the role is that BSS can play?
Yeah, and that is actually quite interesting if you think about how energy markets change and how the needs that energy storage can fulfill in those markets change. The first project, so when I started 10 years ago, we put a 5 megawatt battery into the German primary frequency relation market, which was basically back then the only market energy storage could participate, but where it was very good at doing so. And therefore, in many markets, like in PJM, it came up first, and in the UK with the enhanced frequency response tender, We saw energy storage providing primary frequency response, just reacting really, really fast and very, very precise to signals from the grid. We then moved further. I think in the UK, we had in the capacity market coming in, energy storage providing dispatchable capacity. And today we have a really big number, I think 6, 7, 8 European markets where energy storage participates in capacity markets. Belgium is, of course, one of them, with I think around I think it was around 800 megawatt hours clearing in the last capacity market auction in Belgium. We've seen historically, I would say, not so much that batteries were deployed in day-ahead markets and intraday markets. And I think part of that was the cost of batteries and actually the price delta that you would need to realize, or which would justify the degradation of the battery cells, which comes with every cycle. But as battery prices have decreased, and I think they have decreased by 95% since 2010 or so. It's like
there's also this as part of the IEA study. There's also like this graph circulating on LinkedIn a lot now, which draws the parallels between the solar PV cost curve evolution and the evolution of battery.
So the price degradations are huge, and if we listen to our suppliers, costs will continue to go down. The battery cell chemistry will continue to improve with higher density cells, longer lifetime of battery cells, so they can run more cycles because we have an end of life of the battery cell. So it's going to continue. And as the technology itself gets cheaper and we get more and more renewables into our power grids, we will see more and more applications coming up for storage. So the continuous intraday in Germany, for example, is very strong. And now it really depends, where will we see market signals which incentivize energy storage to come in? We are seeing in Ireland, UK, and in Italy, for example, at the moment, government tenders to bring long-duration energy storage or long-duration energy storage tenders for those markets. However, for them, long duration is up to 8 hours. So some people would say long duration is a 100-hour battery. So in an 8-hour environment, lithium-ion is likely to own and that market and win most of it. At a later stage, maybe we want to get to 10, 12, 15, we're probably going to see redox flow. But there are a bunch of new technologies coming to the market as well. I think the big challenge at the moment is to understand what need are those batteries or those technologies fulfilling, and how do we pay for this need? So we know there is the Dunkelflaute, but how often is it? How valuable is electricity to be moved there? Do we need a curtailment capture product, for example, to incentivize that? Do we need to run through some sort of CFD schemes? Is capacity market the right mechanism here? Do we need subsidy schemes or energy storage support schemes, which are now enabled by the reform of the electricity market design on EU level going forward? So it's a big question, really. I think we very well understand like the very short-term need. We understand like the daily needs, but this will probably bring us to like 80-85% renewable penetration. But then to reach the final 10-15% of decarbonizing energy systems, we'll need to understand which technologies we need to enable that and which market mechanisms should we have for that.
Yeah. And it's probably, or at least that's my personal vision, that we won't have like one single mechanism or one single technology sort of ruling all the others. It's a topic we see often like behind the meter with our customers, where you see often a mix of some process implicit flexibility. For instance, if they have some cooling buffers, some heating buffers, but activation times can of course be a little bit long, so they do not fit well within real short-term demand response kind of mechanisms, but they can do some price arbitrage behind the meter. For other customers, a battery does make sense. Also, for instance, what we see a lot is companies thinking about large commercial fleets, sometimes heavy trucks, for instance, the electrification, where you also have network and grid constraints very locally that can be resolved with large batteries, or they have a specific name, but they basically allow you to boost the grid temporarily to run these kinds of use cases. Like you're of course more native to the big bold batteries, like the in front of the meter grid scale environments, but what's your view actually on those companies that adopt some smaller scale behind the meter type battery storage. How do you see that? That evolving.
Yeah, I think it's actually very, very exciting. So, I mean, first of all, I think what we need to do is we need to define a need technology agnostic. So we need to define, we need that kind of flexibility for that kind of period, maybe that ramp up, or it needs to be available within a certain time frame. And then we should really look at which technology in a market-based setting is able to deliver that. Like I often like to say, that's actually also great about energy storage. So if you build a gas peaker, it will be there for the next 40, 45, 50 years, right? You create a technology lock-in. With energy storage at the moment, as they're utilized, we talk about a lifetime of 15 to 20 years. So if in 15 or 20 years, another technology is cheaper, it makes more sense. Maybe we have huge EV fleets in the market and they come at marginal to zero cost in providing flexibility. Hey, then maybe those will be the assets. Battery storage installation will not find a reinvestment. The same actually with second life battery cells. Let's find a market and figure out if they will integrate or not. If we talk about behind the meter and aggregation of things, I think the same principle is there, right? We need to define the market space in which they can participate. This being said, I see some barriers which need to be overcome or unlocked, which we don't have for in front of the meter installations. So the whole rules for aggregation, think about Germany, small meter rollout, which we don't have, right? So there's a lot about metering concepts, measuring concepts. I think there is an element when you aggregate batteries on a low voltage level and you have a need on the extra high voltage level, how comfortable will the TSO be to procure a specific service that he requires an extra high voltage from low voltage, because it needs to run all through the voltage grid. So that might be a challenging one. I think another element is that the primary use case of a residential battery is actually not to provide flexibility to the grid, but to the behind the meter customer. So the optimization is not, should I discharge my electricity in the evening when the electricity price is high? No, I don't, because I'm optimizing myself against the retail tariff. So I have probably different site conditions in optimizing those assets, which will mean they will come in different timeframes for different kind of flexibility than in front of the meter installation. But overall, we'll need all of those different technologies. If you think about the huge solar peaks, well, of course, residential battery typically is connected to solar anyway, right? But if we have a big storm front, if we have wind in there, then the residential batteries should soak up that wind if it cannot be otherwise be integrated into the market. And so that is another kind of flexibility that they can provide.
Yeah, indeed. But yeah, we often say, like, don't also like sort of overthink your investment case into a battery behind the meter by sort of having to bank significantly on in front of the meter optimizations, because then it starts becoming quite complex and sort of uncertain how the future will evolve. So we always frame it as, look at your optimization potential behind the meter, and it can be done, for instance, as you say, auto consumption improvement of solar. But for large industry, they have so much consumption that we typically spin it around the price arbitrage that you can generate. We see these intraday price fluctuations or day ahead price fluctuations being very large. Some of the industrials are exposed to the intraday, some not, but then day ahead they're still significant. And as well, it's not just a commodity that starts fluctuating in price a lot. It's also the TSOs and the DSOs, at least in Belgium we see it, imposing or implementing more location-specific and time-specific grid pricing too. Because congestion of the grid, of course, is a major topic, and if we can use behind the meter assets to grease a bit the investment rollout that all these grids need, it's of huge value, of course.
Yeah. And I think this is actually a huge value where exactly like behind the meter solutions can come in. So at the moment we have markets for energy markets where energy storage can come in, but we don't have market settings for congestion management. Even though based on EU regulation, even from the Clean Energy Package from 2019, there is the option of flexibility markets for market-based congestion management. We're now discussing a network code for demand response on EU level, which will ask for local markets for voltage regulation, congestion management. And of course, as behind the meter assets are sitting behind behind on the lowest voltage, so potentially behind a lot of levels of potential congestion, they should be taking a key role in unlocking this congestion. We just need to organize a market and provide price signals to it. But of course, easier said than done.
Yeah, many interdependencies, of course, across the different mechanisms. Also between countries, it's not always harmonized. We often see quite some misconceptions around the concept of storage and batteries. We hear, oh, batteries will just flatten all prices in a couple of years. There will be no fluctuations in prices anymore. We hear like batteries are just good for storing some solar energy in summer and then consuming it in winter. I mean, we were discussing the long term, and some people call 8 hours already long term. Let alone what seasonal sort of pass-through would be called. What are some of the most common misconceptions about storage that you come across and that you'd like to get out of this world?
Well, I think you mentioned a couple of them already, right? I think one that I always like specifically struggle or get annoyed on, and I'm working on a LinkedIn post on that actually, is the notion, well, all the hydro pumped and residential and utility scale batteries in Germany can only store the 4 minutes of the energy requirements in Germany, so they don't have any purpose, right? And I mean, I really from 2 points, this is kind of wrong from my perspective. I mean, first of all, we're just in a huge ramp up of energy storage in the world. So it's like of saying like when the first automobiles were introduced and everybody was riding a car and people would say, well, this is never going to work. It's not a horse, right? And it's like, yeah, I mean, we're just at the threshold where we're now starting to integrate a lot of storage in the market. And I mean, just the utility scale storage market between today and 2030 will grow sixfold, as we said before. So it's a huge growth. But on the other side, it's not the purpose of energy storage to satisfy the load in Germany or any country. It is like greasing the energy system and integrating renewables. It's never meant that energy storage functions as a backup power asset for the whole grid. And even in the Dunkelflaute, there's actually still a lot of renewable generation in there. Well, not enough, but there is still a lot of. So it's not a matter of in the Dunkelflaute, the battery park would have to cover 2 weeks of the German load of 80 gigawatt. No, that's not the point, but it will have to balance out the peaks that even then occur. So this is one I always think like when somebody comes up with that they just don't get the concept, which is okay, but I think many people just don't want to get the concept as well because they say, oh, we need to stick to nuclear, we need to build gas peakers, we cannot change, and I think we need to help educate how the energy system needs to change and which role energy storage can play in that change.
Yeah. Or nothing about lifting big concrete blocks in the air and hoping it would provide a better storage technology than electric batteries.
Yeah, well, I should not talk about competitors and different technologies. Look, as long as we have a market structure, then we will see which technologies will be awarded. So I always find it very difficult if somebody says we're building a, I don't know, 200, 500, whatever, megawatt pilot in China, because that is in China. I don't quite understand the market mechanisms there. Bring it to Europe, right? Of course, energy storage based on lithium-ion cells, of course, has a huge advantage that it's bankable. We have technology experience with it. Prices decreasing not because we're building a lot of energy storage or stationary storage, but because of the EV sector. But in the end, look, just let's create markets in which different technologies can compete. And then if moving concrete blocks up and down or water down a coal mine or trains up and down a hill, that is another gravitational energy storage technology I heard before. Well, if they are better, then be my guest, they should come into the market and compete and lower energy prices for consumers.
Yes, that's of course the goal. Maybe another thought, like Fluence, you're focusing on very large scale battery parks. You're obviously then very good in all things batteries as a company. Most industrial companies are not. They're not acquainted with the concept of electric batteries and sort of the operational financial constraints that come with such an investment.
Yeah.
What are, according to you, for companies that are starting to look for a battery, a potential battery investment? What are the critical success factors that you, as a battery specialist, would suggest looking at or considering?
Yeah, I mean, we also see a lot of customers, utilities procuring batteries for the very first time, and we see big learning curves there, of course. So, what I would say, what is always important is don't just look at the price, but look what's behind the price. So we like to talk about TCO, the total cost of ownership, which is looking at the value over project lifetime. So you can get a very cheap battery at a low price, but then maybe it has a worse round trip efficiency. It has worse degradation, which basically means the battery doesn't last as long as a battery that might be a bit more expensive, right? It might have higher auxiliary load consumptions. So basically, it's cheaper up front, but you spend much more energy maintaining the battery. So from our perspective, taking a view on the lifetime cost of an asset is always quite important. I think another element is that what we've seen in the energy markets in the past years, they are changing. They're going to change. You can't do anything about it. Have an asset which can change with the market, changing market. We've seen that in PGM where batteries were built specifically for market, and the cycling of that market changed, and all those batteries had to be derated because they didn't have sufficient cooling equipment with it. So you should have a software platform, like the management platform, which is adaptable to change to new market signals, to new market products, which might be introduced, right? But at the same time, your asset should not have like a fixed warranty or guarantee, but you should, like, we have a flexible performance warranty. Others have that in the market as well, where you can basically, maybe at the moment you only cycle your battery once a day because you're co-located with solar on your roof. But maybe in 5 years' time, you want to cycle it twice or 3 times a day. The performance warranty should somehow be able to mirror that changing need. What we also see, I mean, especially, of course, if you think about behind the meter, integrating batteries into critical infrastructure, fire safety is an important element that comes in where there are international best practice standards established. We also see ESG requirements becoming more and more important to some of our customers. So how was the battery produced? What is the CO2 footprint, supply chain due diligence, where the minerals come from, and so on. I think these are also other elements that we're seeing. But I would also be interested if you see other critical factors that you think are important for procuring batteries.
Well, yeah, our main point that we often bring is about the remuneration or the payback of that investment, and also just making sure there is a core base layer of just a decent and sound financial case on your turf, on your site, on your operation as a company, and not being overly reliant or dependent on market mechanisms that will develop in the future, maybe, or all those kinds of highly conditional topics. So we try to convince companies to focus on what they are good at, what their operation is, and making sure that a battery fits in that context, together with other types of flexibility, other types of just energy management, basically as a whole. Storage in the end is just one factor in the machine of energy procurement, energy sustainability operations. So yeah, it's quite a big exercise for many companies navigating this trend.
Yeah, that makes a lot of sense.
Cool. But Lars, we're at 30 minutes. Thanks a lot for your great inputs. Liked the talk and learned again a lot from you. So thanks for making the time, and we'll be in touch later for sure.